All right, example 2. It says here there's a formula for a t-test on the correlation coefficient. It says for a t-test of the correlation between two variables, the test statistic for the p is a sample correlation coefficient r and the standardized test statistic given by this formula, where n minus 2 is the degrees of freedom. And so we'll see that as we go through here on the next problem. All right, so it says here, in example 1, you determine the correlation coefficient R for the manager experience. The salary was about 0.9155. Test the significance of this correlation coefficient at the 5% level. So basically, we're using this formula to try to come up with this T, or the significance. So that's what we're going to come up with, this t-test, to find out the significance of this. So here's what I'm going to do. I'm going to walk you through where this graph comes from, and then we'll test the significance. So we know that alpha is 0.5%, which is 0.05. So I have that. And as you can see here, we're testing this two tails. So I need to leave this as two tails. I'm going to go over here to the alpha visualizations, and we're doing a t-test. So t distribution and the degrees of freedom, according to this document here, where we just were, is you take away 2 from the samples. There was 20 samples, and so when I subtract 2, I should get 18. And you'll see this t distribution is giving the number t 2.1, which that's that value. And so the left value, the left tail, and the right tail, let me visualize this, you can see is at 2.1 and negative 2.1. So there's their two critical regions here, at 2.1 and negative 2.1. So that's where that came from. Now let's talk about, where does this 9.7 come from? Well, that is if you plug in this formula, which that's a lot to type in. So I have that for you. If you go to the regressions and models and go to your linear regression, you will see the t-test right there. It's 9.65. So you can see that's where they get the 9.7. And it is way out here to the right. Okay. So my t-test provides the value. The t-test is going to equal 9.655. And I'll do squigglies just to say that's approximately, I'm rounding that. That's what I got here by plugging in the values. Again, you would be plugging in the t equals, or the t-test, if you will. The square, the r was 0.9155 times the square root of 20 minus 2 over 1 minus 0.9155 squared. If I remember that formula correctly, I'm going to double check real quick. Yes. And these values, that comes from that's the t-score values with 18, which is 18 degrees of freedom, is where those came from. For this providing a 0.025%, or I shouldn't say percent, let me change that to 2.5%, and this being 2.5%. That's the t values, and so that's where all that came from. Okay, now I will let you try this one to determine what you get here for your t value and if it's significant or not. Again, the significance has to do with how high that number is. And so let me go back here. And since this value is past the critical region or inside the critical region, I know this line should continue on, we would say that it is significant. This is significant. Significant at the 5% level. And I should say since the t-test is greater than 2.1, the correlation is significant. The correlation is significant at the 5% level. Okay, so now when you go through this one, if your value falls within the critical region, it is significant. It is significant. And if it's not in the critical region, then it's not significant.